viewers and all these things. I have spoken about that. I have talked to you about different types of walls, diathermic wall, adiabatic wall, allowing exchange of heat, not allowing exchange of heat, what is thermal equilibrium, thermodynamic equilibrium, zeroth law of thermodynamics, why is it called as zeroth law, and in zeroth law what happens, that is A and B with C, then A and B also in equilibrium. These things we have learned in the previous class. I even started talking about first law of thermodynamics, where I told first law of thermodynamics says that del Q is equal to del U plus P del V, or I can say del Q is equal to del U plus del W, which says that whatever heat we supply to a system is utilized in two ways. One is to increase or to change the internal energy of the system, and second is work done by the system on the surrounding. So, if you add these two, then the energy is what you are supplying is equal to that. So, that is what we have learned in the previous class. So, today I am going to start the class with once again talking about a sign convention, because here is where students are doing a lot of mistakes I am seeing every year. So, you should remember the three conventions. You should never forget the convention which says that work done by system is taken as positive, work done on system is taken as negative, heat absorbed by system is taken as positive, heat given away is taken as negative, internal energy increase is positive and internal energy decrease is negative. These conventions should be in your head, because when numerical comes, they will not teach once again these things. A numerical, whether you should take it positive or negative, totally depends upon these conventions. So, these conventions are the base for solving numericals from first law of thermodynamics. One more thing I want to add here, that in the previous class, I not talked much about numericals of first law of thermodynamics. Today we are going to do that. But you should understand, when the formula becomes del Q, let me write it down here. So, the formula says del Q is equal to del U plus P del V or del W, whatever. In this case, you should be very clear in what is the meaning of del Q, what is the meaning of del U, and what is the meaning of P del V or del W. We should be very clear in that. If you are not clear in this, you cannot mug up this formula and solve numericals out of it. Today I will give two numericals to you, you will realize until you are conceptually very strong, you cannot solve the numericals coming from first law of thermodynamics. So, please pay attention. Again I am repeating, I will give time for writing. You have the recording available to take the notes. Understanding is more important. So, in this class, try to listen more. Numerical solving you do, but theory taking, notes taking you can do later also. Let us not spend time on notes taking now. More time should be spent for listening, understanding and solving numericals. That is the aim, right? So, please pay attention. Del Q is the heat energy that we are supplying. I said you, if you have a system like this and suppose I am giving some energy to it, I can give the energy in form of heat or anything else. What will happen? It will change the internal energy of system. I told you what is the meaning of internal energy also. It is the combination of molecular kinetic energy and molecular potential energy. If the volume is increasing, its potential energy is increasing, because configuration of molecules will change. If its temperature is increasing, its kinetic energy is increasing, because molecules will become more faster. So, when you supply some heat, this is what is del Q, okay? The heat that you supply, that is used for increasing or changing the internal energy, and if this piston moves up or down, then that is the work done by the system on the surroundings. It can be vice versa also. So, this is the work done, this is the internal energy change, and this is the heat supplied. These three relation only is called as first law of thermodynamics. Very simple, isn't it? You have a system, inside gas is there, piston is there, I heat. What will happen? Piston will expand and the gas will become hot. The gas becoming hot is the example of change in internal energy. The piston getting expanded is the example of work done by the system on the surrounding. So, it is common sense that what heat you are supplying is used in these two ways. That is the meaning of first law. Now, in the numericals, del Q you have to find a lot of times, and how to find del Q is taught to you in the previous chapter, thermal properties of matter. I will recall once again, some of you may not be remembering that. One thing is del Q is equal to mc delta T. You remember this? What is this? This is the heat energy supplied to change the temperature of a gas, in this case gas, at a constant state. That is, I told in the previous chapter to you, if temperature is changing, state will not change. If state is changing, temperature will not change, isn't it? So this formula we have to use when? When an object means a system is changing its temperature at a constant state. Or else, another formula of del Q is ml. You remember this formula? This is the formula we use for latent heat. If there is a change in state and temperature is remaining constant, what we are going to use? We are going to use del Q is equal to ml. It can be mlf or it can be mlv. If it is fusion, it will be mlf. If it is vaporization, it is mlv. So understand, if a question is given to you where ice is getting converted into steam, or let me make it simple, ice is becoming water. Please pay attention, everybody. I will ask questions from you after this. So if you are having minus 10 degrees Celsius of ice and you are making it minus 10 degree of ice into 30 degree of steam. Let me assume this process. In that, when the ice from minus 10 degree is reaching to 0 degree, what formula you are going to use out of these two? MC delta T, isn't it? Because ice remains ice, just the temperature is changing from where to where? Minus 10 to 0. So you will put the value of M as how much ever ice, suppose 2 kg of ice is given. Then you will take the value of this M as 2 and you will take the value of C, it will be given in the question, and del T will become 10 degree. Because it is from minus 10 to 0, subtract will become 10. Then minus, that is 0 degree of ice will become 0 degree of water. 0 degree of ice becomes 0 degree of water, am I right? That 0 degree of ice becoming 0 degree of water is what process? What process is that? Latent heat. So which formula you will use? ml you will use. Once again, the 0 degree of water will become 30 degree, so 100 degree of water. What formula you will use for that? MC delta T, because water is becoming from where to where? From 0 degree to 100 degree. Then once again 100 degree of this thing will become steam, that you will use. So I am just giving you an example that whenever there is a change of state and change of temperature happening simultaneously, you are required to use accordingly. Don't confuse how to find del Q. Del Q you will find only by this method, either by using MC delta T or by using ML, MLF or MLV. Clear? And P del V is the work done. So change in volume will be given to you, pressure will be given to you. I will make it more clear with some numerical in today's class. Okay. So without wasting further time, let me directly jump into the numerical. So these things we have studied in the previous class itself, if I am right. So let me directly go to the numerical. Yes, yes, yes. It is in front of you, all of you. 5 minutes of time I am giving, 5 minutes of time. So solve this, try your best and we will discuss it. Read the question and start solving it. 5 minutes I am giving you. Don't try to find in Google or any other reference. Do by yourself. Do mistake, but do by yourself. Try. It's a question of first law of thermodynamics. You have to find del U, isn't it? Change in internal energy. And by the data given, you have to extract and find what is del Q and what is P del V. It is totally your skill of solving the question. Give your best. Try. C means MC delta T you are saying. No, yeah. This 1671 is volume. CC means centimeter cube. CC means centimeter cube. Don't confuse yourself. Still 2 minutes are there.
Sir, 2089 too, sir.
2000?
89, 2089.
Okay. Anybody else? Any other answer?
2089 only, sir.
Good, Sai Akhilesh. I don't know if it is right or wrong, but it is looking like right only. Anyhow, let us check it. Last 1 minute. Those who have solved, just verify your answer once before I solve it in front of you. Those who are solving, last 1 minute for you. Give a try.
Sir, I got in 2089.
Okay, Niranjan, so you agree with what they have told?
Yes, sir. 2089.
Okay, so multiple people are saying the same answer. It may be correct. So, others, still you have 40 seconds before I start solving it. Avanish, what you are finding the answer somewhere? Time is up. Avanish, what you are doing, man? Your eyes looks like you are staring some screen. Are you hearing me, Avanish? I am taking your name. Or he has muted and he is playing some game. Avanish, I am asking something to you if you are hearing me.
What, sir?
What you are doing? You are waiting for me to solve.
No, sir.
Then
I didn't hear you first.
okay, but you are not. Does not look like you are solving the question itself. You're looking like you are seeing something else. Okay, anyhow, please pay attention. I am solving it now. So now, Leah Varshini, unmute yourself and tell me what is the given data. What is given in the question? Make it fast. Don't take too much time. Yeah, tell me fast.
1 gram of water.
That
It
is.
is converted into steam.
Don't read the question. I am asking given data. Make the data into roster form and tell me. Mass of water is given. How much? Leah Varshini, I am unable to hear you. Please tell. Unmute yourself. You are muted.
Yes, sir.
Yeah. What is the mass of water given? What is given here?
1 gram.
Say 1 gram then. Who will say? Convert into SI units. It will become 10 to the power minus 3 kg, right? 1 by 1000. Yes. What else is given? Leah Varshini.
Volume.
Volume.
Volume of the stream.
Volume of steam is given. How much is that?
1671.
Centimeter cube, which is equal to 1671 into 10 to the power minus 6 meter cube. Am I right? You have to convert it SI units. If you are not doing it, you will be having a trouble. Okay, anyhow. What else is given?
Latent heat of the stream.
Okay, LV is given. 2256. Again, joule per kg. So 10 to the power minus 3 it will become. Isn't it?
Yes.
Joule per gram it is given. Yeah, I am converting it to joule per kg.
10 to the power 3 now, sir.
10 to the power minus 3 will come. Yeah, it will become 3. Sorry. Plus 3 only it will become.
3.
Yeah, positive 3. Because it is in denominator. Fine. Anything else given, Leah Varshini? One more thing is given. You are not minding that one thing. Temperature is also given, no?
Temperature 100 degrees
Yes.
Celsius.
Yes. Okay. Kirti, unmute yourself.
Certain other way, sir.
I'll come to you, man. Kirti, unmute yourself. Yes. Tell me, what is the formula of first law of thermodynamics?
Q is equal to
Del U plus work done is P del V. Am I right, Kirti? Okay, so in this question, tell me which formula of del Q will be using? MC delta T or MLF? ML, very good, ML. So, what we want to find in this question? Del Q, del U or P del V? Del U, very good. So, what will be del U? Del U will become equal to del Q minus P del V, right, Kirti? Yes. So, what will be the formula which you will be using for del Q? M, L, ML, MLV in this case. So, M is 10 to the power minus 3 and LV will become equal to 2256 into 10 to the power 3. Am I right? Okay. Minus. What would be the value of pressure in this case? Pressure is not given.
Sir, atmospheric pressure,
How
sir.
much is that?
100 to the power 5.
Yeah,
Okay, roughly.
10 to the power 5 directly, I'll write.
Yeah.
Kirti, you should not forget this basic atmospheric pressure here. It is 10 to the power 5 pascals, right, Kirti? Okay, what is del V?
167.
No, 1671 is the volume of steam. It is not the change in volume. If you are taking 167, it is wrong. So, what is the correct thing? Anshul, can you tell me? Yuvan Shankar, what is your opinion? How to find del V?
No idea, sir.
Okay, Sugindran, he's there.
Yes, sir.
Yeah, man. Del V, how to find?
No idea.
Okay, Shivaranjani, do you have any idea how to find del V? At least unmute, yeah. Okay, coming to Sai Akhilesh, who has solved. Yes, how did you find del V? Tell me.
Sir, density of water, sir. So with density of water, volume of water we can find, sir. Volume of steam minus volume of water.
Very good. Here they are saying 1 gram of water is becoming steam. So you will find the volume of water first, not given in the question. How will you find volume? Very simple. Density is equal to mass by volume. So volume of the water will become equal to mass of water, 1 gram. What is the density of water? 1 gram per centimeter cube. So 1 by 1 will become 1 centimeter cube butter, right? So how much it will become? 10 to the power minus 6 meter cube. This is the value of volume of water. Do you understand this, all of you? Very basic thing we are doing. So volume of water is known to us, volume of steam is known to us. Now we can find change in volume, right, Kirti? That will become equal to 1671 into 10 to the power minus 6 minus 10 to the power minus 6, right? When you solve this equation, this minus 3 plus 3 gets cancelled. You are going to get 2256 here minus, if you solve this, it will become 10 to the power minus 6 outside. So 10 to the power 5 already is there. Into 10 to the power minus 6 I am taking outside. What is going to remain? 1671 minus 1. It will become 1670. Understanding? What I am doing, you are understanding or not? 10 to the power minus 6 I have taken outside. So 1671 minus 1 will become 1670. Now when you solve this, it will become, how division it is there? It is not by, it is multiplied. ML here, M is 10 to the power minus 3, L is 2256 10 to the power 3. It is in multiplication, not M by L, it is M into L. Okay? So 2256 minus, this will become 10 to the power minus 1, so it will become 167.
167, sir.
That's all.
Yeah, so get 2089.
2089 joules.
Joules.
Is it clear? Is it clear to everybody? Simple question, isn't it? That is how the questions will be asked. Are you feeling? They will give some clue to find del V, but here del V was not given. They gave 1 gram of water is becoming 1671 centimeter cube of steam. So you have to use your basic knowledge and understand what is the value of change in volume. If you are taking this volume value as delta V, you will get wrong answer. I hope it is clear. Is it clear? Can I proceed further? I am going to the next page now. It will get erased. I am erasing this page. Shall I? I hope I can. Okay. So next, another question. Fast. Again 5 minutes. Don't take much time. Solve it. Similar kind of question. Give a try.
Sir, can I take a PDMS 105, sir? Again.
Yeah, you can take. It is 1 meter cube of water is converted into 16771 meter cube of steam at atmospheric pressure and 100 degrees Celsius. LV is given, and if 2 kg of water is converted into steam at atmospheric pressure and 100 degrees temperature, how much will be the increase in its internal energy?
So the answer is coming in negative, sir.
How it can come in negative?
Negative only coming, sir. Negative
Yeah,
minus
sir.
1624 into 10 to the power 6 joule coming.
Loud.
Same, sir. Same.
One second. What is the answer you are getting? Tell me again.
Minus 1624 into 10 to the power 6, sir.
Some mistake is there. Check. Read the question once again. Some mistake is there.
W is equal to Q delta
Some
Q
mistake
minus
is there, I
W,
told
sir.
man. Check once. I will solve it on the board. Don't worry. What mistake you are doing, you try to find it out. Still 2 minutes are there. Try. Last 1 minute. Last 10 seconds. Time is up. Right. So, same answer, negative answer, Akhilesh, Pratap, Abhinand.
Yes, sir.
Okay.
Yeah, sir, I don't know where I'm going wrong. I don't understand the question.
Let us check. Let us check. Let us check. Let us check. Okay.
Okay, sir.
So now, Pavitra, tell me what is the given data. Unmute yourself and tell me the given data fast.
Mass of the water is
How much?
1 meter.
Mass is in meter cube. Pavitra, think and say. 1 meter cube means it is volume, no? Yaar? So volume of the water is 1 meter cube, you are saying. Okay. What else? Tell fast, tell fast. Keep on going. I am not able to hear you if you are saying something. If you are not saying something, please say something. I am just asking given from the question, nothing else I am asking. Try, Pavitra. Are you saying something? I am unable to hear anything what you are saying. Please check your connection if you are saying something. Let us come back to Jivika. Unmute yourself.
Yes, sir.
Please tell me what is the given data.
Volume of steam is 1671 meter cube.
Volume of steam is 1671 meter cube. Okay. Next what?
Temperature is 100 degrees Celsius.
Okay. Temperature is 100 degrees Celsius. Then what else?
Latent heat of vaporization is 2.3 into 10 to the power 6 joules per.
Okay. 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 What else?
Mm,
Then what is this 2 kg, Jivika?
Mass
Of?
water.
So can I take mass of water is 2 kg?
Yes, sir.
Okay. What else? So one thing is confusing here. Why they have told 1 meter cube of water is converted into 1671 meter cube of steam? You know why? Any idea? Yes, now Sai Akhilesh or Pratap, you unmute yourself. Tell me,
Yes, sir.
the formula of first law of thermodynamics is del Q is equal to del U plus P del V, right?
Yes, sir.
Yes. Here they are asking to find del U, right, Pratap?
Yes, sir.
And del U will become equal to del Q minus P del V?
Yes, sir.
Right, very good. Del Q, how will you find, Pratap?
Del Q can find using MC delta T, sir.
mc delta T. Temperature is changing here.
No, sir, ML.
ml. Okay, tell me the
Mass
form.
related meter.
Okay, what is the mass you are going to take?
2 kilograms.
And what is the LV you are going to take?
Latent heat value is 2.3 into 10 to the power 6, sir.
Good. Minus, what is the pressure you are going to take?
Pressure, atmospheric pressure.
10 to the
10
power.
to the power 5.
Okay. What is the del V you are going to take?
10 to the molecules are 1600. Sir, one doubt, sir.
Tell me.
Sir, 1 meter cube water means 1000 liters of water, no, sir, but 2 kg only is given mass.
Yeah, that's
Same dude.
exactly. Now, 1 meter cube of water is converted into 167 meter cube of steam. What you are doing, Pratap, Sai Akhilesh and Sai, what is the name? Abhinand. You are subtracting 1671 minus 1 and you are taking the value of del V as 1670. Am I right?
Yes, sir.
Yeah.
But see the question, understand the question first. They are not talking about 1 meter cube of water itself. They are talking about 2 kg of water.
Yes, sir. Okay, sir.
Do you think that 1 meter cube of water is 2 kg of water?
No.
Then there itself you failed, no? Are you getting?
It is right, sir.
So you have to find this 2 kg of water can create how much steam?
Yes, sir. Okay, sir.
Are you getting?
Okay, fine.
2 kg of water, the volume of 2 kg of water you can easily find. How you can find? Density is equal to mass by volume. So volume is equal to density by mass. Mass by density. Mass is 2 kg. Density is how much?
Okay.
2, sir.
One.
2 meter.
10 to the
2
power
star.
3 kg per meter cube.
2 meter cube, sir.
So it is going to be 2 into 10 to the power minus 3 meter cube, no yaar?
Minus 3 meter cube.
Yeah.
Sorry.
This is going to be the volume of 2 kg of water, am I right?
Yes, sir.
We also want to find how much this will create steam. That is also not given to you. You cannot take it as 1671 because 1671 meter cube is for 1 meter cube of water. Please understand this logic. Good question this is.
Okay. Alright.
They are telling that 1 meter cube of water is only becoming 1671 meter cube of steam. Now in this case, they have told 2 kg of water, and 2 kg of water is 2 into 10 to the power minus 3 meter cube. Why they gave this statement to you? Because they wanted to analyze this, and from there you have to find V of steam. That is 1 meter cube of water is converted into 167 meter cube of steam. It means 2 into 10 to the power minus 3 meter cube of water will convert into 2 into 10 minus 3 multiplied by 1671 meter cube of steam. Do you agree with me?
Yes, sir.
How much will be that? 167 multiplied 2, 14, 4 upper 1, 13 upper 3342 into 10 to the power minus 3.
Minus 3, sir.
Do you understand?
Yes, sir.
Now this Vs is known to you, Vw is known to you. Subtract both, get delta V. Are you clear in this? So what will be delta V? Delta will become equal to 3342 into 10 to the power minus 3 minus 2
Minus
into
10
10 to the power minus 3. Do you agree with me? Now your answer will come. See here, it will become 4.6 into 10 to the power 6 minus, here I am taking 10 to the power 5 and 10 to the power minus 3 common, then I am going to get 3342 minus 2 will become 3340. Do you agree?
Yes, sir.
So it will become 4.6 into 10 to the power 6 minus, how much is going to come here? 3340
10 square.
into 10 to the power 2, right. So do the subtraction, how much will be that, you calculate, and that much joules will be the answer. Got it?
Yes,
Got it,
sir.
sir.
I hope you understood. See, the questions are logical question. In physics, in 11th or in 12th, if you are thinking that you know a set of questions and you can get good marks, you cannot get. It is not about mugging up the things. It is about understanding the thing. First law of thermodynamics, del Q is equal to del U plus V del V. How to put the values and get the answer. Just because 161 is given, 1 is given, I will subtract and I will get. It is not a logic. Yes, read the question properly. If you are making a mistake like this, that means you are not reading the question. Given is there, somehow getting the answer. Very clearly told, 2 kg of water we convert into steam at atmospheric pressure. How much will be the increase in its internal energy? Then how dare you take 1 meter cube as the initial volume for this? Do you think 2 kg and 1 meter cube are same? That is where you should have stopped yourself. All of you should know 1 meter cube of water means 1000 kg of water. Am I right? In 1 meter cube, how much water can come? 10 to the power 3 kg can come. Basic sense. That itself you are not applying means not good. Is it clear? Sure? I hope everybody is clear in this. Shall I continue further? Let us go into the derivations and other topics now. But solve some more numericals. I will share the worksheet if you want. In the group I will share the worksheet of thermodynamics. Please solve numericals from thermodynamics to become strong in this. Shall I proceed further? Allow me.
Yes, sir.
Thank you. So now let us move further. In this, after learning about the first law of thermodynamics, we must learn about specific heat or specific heat capacities. So we have two things here. First of all, what is the meaning of specific heat? Specific heat is not a new thing. Specific heat is known to you from the previous chapter itself. I said you that how much heat is required to increase the temperature of unit mass of substance by unit degree Celsius is called as specific heat of that substance. Remember this? If you have 1 kg of iron and you are supplying heat to increase its temperature from 23 to 24, how much heat you are supplying to it? That heat is called as specific heat of iron, right? So specific heat means heat supplied to a unit mass of substance to increase its temperature by unit degree Celsius. Okay. Now, in the case of gas, it is a bit different. So, once again, if we'll come to that. So, in this case, what is the meaning of specific heat? It remains the same. It is the amount of heat required to raise unit substance by unit degree Celsius. It's not required, but this was the formula of that, right? Q is equal, C is equal to Q by M delta T. You remember this? From here only we have got the formula of Q as MC delta T itself. From here only we have got the formula of Q as MC delta T. So, C is what? Specific heat, isn't it? So, it is known to you. Now, in the case of gases, we have molar specific heat concept, because now we are dealing with gases. Usually we will not talk about meter cube of gas, kg of gas. We will talk about moles of gas, 2 moles, 5 moles, 10 moles. So, when we say molar specific heat, nothing changes. We will use the term as 1 mole of substance, not 1 kg. In the case of specific heat in terms of mass, we say that amount of heat energy required to change the temperature of unit mass of substance by unit degree Celsius. Now, we will say amount of heat energy required to change the temperature of unit mole of substance by unit degrees is known as molar specific heat of substance. Are you getting my point? So, molar specific heat will be, the formula will be Q by N delta T. So, in the case of, I will write it here, in the case of normal specific heat, how we write? We write it as small c is equal to Q by M delta T. In the case of molar specific heat, we are using capital C. Remember that capital C will become equal to Q by N delta T, where N is number of moles, M was mass, isn't it? Unit mass, unit mole. So, this is the formula for specific heat generally of gases. Are you getting my point? Molar specific heat of gas is given by Q by N delta T. If I take 1 mole of gas, for 1 mole of gas, N becomes equal to 1. So, I can write C is equal to Q by, or books will write del Q by del T. So, del Q by del T is the formula of molar specific heat, but the gases do not behave like this liquid or solid. If you have solid, you can take it, you can keep on a stand and you can heat, isn't it? If I am having a brick, I will take a brick like this, I will just keep the brick on some stand and then I will put a burner below. I can check for temperature becoming from 23, 24, how much is the amount of heat energy required. Easily you can find. If it is liquid, you can go back. If it is liquid, what we do? We take a container. In this container, we keep some liquid, and this liquid we are going to heat it, and then we find 2 things: apparent specific heat. Remember this? I have talked about this in the thermal properties of matter, where I have told you in this case heat supplied to the liquid will be taken by both container and the liquid. So, we will find the real specific heat and apparent specific heat. You just check your notes. I have told about this in the thermal properties of matter chapter. Now, we are talking about gases. The thing with gases is that when you are heating a gas, there are 2 possibilities. One thing is you can keep the volume constant, that is you have the system and you lock the piston, this will not be moving, and then what you do? You supply heat and check how much heat is supplied to increase the temperature by 1 degree Celsius. That will be called as molar specific heat at constant volume, because volume is not changing. But in nature, naturally what will happen? When you are heating it, the volume will increase, isn't it? But if I am trying to maintain the pressure as constant, then what will happen? Whatever heat you are supplying is used for 2 things. One is to raise the temperature, another is to move the piston upwards. And you calculate how much heat is required to change the temperature by 1 degree Celsius. That will be called as molar specific heat at constant pressure. This is called as CV, this is called as CP. And I have told to you in the previous class, I think some class I remember I have talked about this, that CP will be always more than CV. What is the reason for that? Common sense says, see, here less heat itself will make the change, because the volume is not changing. But here you need to supply more heat, because the heat you are supplying is used for two purposes. One purpose is to increase the temperature, second purpose is to do some work by the system or the surrounding. So, some energy is lost in P del V, that is why more heat energy is required to change the temperature by unit degree Celsius, and that is why Cp is always more than Cv. So, whatever I have spoken now, the same thing will be there in the slide, upcoming slides. That is, there are two kinds of specific heat. One is called as molar specific heat at constant pressure, another is called as molar specific heat at constant volume. So, at constant pressure, the same thing, it is defined as the amount of heat required to raise temperature of 1 mole of substance through 1 degree Celsius while keeping the pressure constant. And what will be Cv then? Same for definition, keeping volume constant. So, if you are keeping volume constant, it is Cv, keeping pressure constant, it is Cp, right? But the meaning is same. Meaning is how much heat energy is supplied to raise the temperature of unit mole of substance by unit degree Celsius. At constant pressure, Cp. At constant volume, Cv. Why Cp is more than Cv, it is clear to you? Because in Cv, whatever heat you supplied is used only for one work, increasing temperature. So, it will need less heat to increase temperature. Whereas in Cp, your heat energy supplied is doing two parts. One is del U, one is P del V. So, more heat is required to increase the temperature by 1 degree Celsius. That is why Cp is more than Cv. Is it clear to everybody? Anybody has doubt, you can ask me. I hope there is no much doubt in this. So, the same thing they would have talked here also experimentally when they are doing constant volume. Then del Q will become equal to del U, because del V will become 0, isn't it? Constant volume means no change in volume, del U is 0, del V is 0. If del V is 0, del Q will be purely equal to del U. And in this kind of scenario, whatever heat you supply, that will go only to change the internal energy of system. Whereas in the case of constant pressure, what is going to happen? Whatever heat you supply, it will be used for both the works, del U and work done. That is why the value of Cp is always more than Cv. Anybody has doubt in this? I don't think you have doubt, because the question comes in the examination. Cp is more or Cv is more? Obviously Cp is more. Why Cp is more? I have explained it to you. Is it clear? Notes you can take later, don't worry about notes. But I hope you are understanding the Cp-Cv concept. Okay. Then there is something called as Mayer's formula. I have not given here, I will derive on the board by myself. So, have you heard about Mayer's formula?
Yes, sir. Cp minus Cv equal to R.
Cp minus Cv is equal to R. How that formula has come? How that formula has come, you know?
The Q equal to mc delta T at constant volume.
Yes, we will do that now. So, Mayer's formula, as told by SI Akhilesh, Cp minus Cv is equal to R. Very correct. Let us try to find how the value has come. So, you know very well what is the meaning of Cp. Cp is molar specific heat at constant pressure. And I told you Cp now the formula is del Q by del T. This is the common formula. And then in this case, what is del Q? Del Q will become equal to del U plus P del V. At constant pressure, it will become equal to del U plus P del V by del T. Am I right? Equation 1. Any doubt in this? Very basic thing I am doing. I am using first law of thermodynamics. In the case of Cv, it will become del Q by del T, but it will become only del U by del T, because since del V is 0. Why del V is 0, understanding? Because constant volume. If volume is constant, no change in volume. Del V will become 0. And now equation 1, equation 2, you just do 1 minus 2, you will get Cp minus Cv. That will become, I am doing 1 minus 2, okay? Equation 1 minus equation 2. Cp minus Cv. Cp minus Cv will be how much? Del U plus P del V by del T minus del U by del T. If you take the LCM as del T, then these two gets cancelled and you get P del V. Now, Cp minus Cv becomes equal to P del V by del T. You know the ideal gas equation, PV is equal to nRT. For 1 mole of gas, for 1 mole, PV is equal to N is 1, so RT. So, P del V will become equal to R del T, because R is a constant. P del V will become equal to R del T. Put it here, you are going to get Cp minus Cv is equal to R del T by del T, these two gets cancelled, you get Cp minus Cv is equal to R. 2-mark derivation in the school examination. Cp minus Cv is equal to R. This derivation is called as Mayer's formula and frequently asked in the examination. Okay, very basic derivation. Cp, I hope you understood how I have written this, and Cv also you understood how I have written this. Subtract both, del u del v will get cancelled, and what you will remain is P del V by del T. P del V is equal to R del T, del T gets cancelled, you get C minus Cv is equal to R. This is called as Mayer's relationship. Okay, it will be used in some next chapter, it will be used actually. KTG, it has a major use. More than thermodynamics, Mayer's formula will have more use in kinetic theory of gases, where I will find the gamma for all the different gases. So can I go to the next page? This derivation you can copy later. I am repeating again. You will let us not spend more time in this thing. Let us spend more time in learning today. Copying work you can do later also. But if you want, I'll wait for 2 minutes. If you want to write something, shall I wait for 2 minutes? Okay, I'll proceed further. I'll proceed further. You can copy it later. I'll share the clip with you, please. Let me not like spend time on waiting. Next. So, what is this here? Yeah. So next comes yes, quasi-static process. Have you heard about this word, quasi-static? What is quasi and what is static? What is the meaning of the word quasi? Anybody knows?
Slow, sir.
Yes, very slow, not slow, very slow. Quasi means very slow and static means at rest, right? So it is very slow as if it is seeming to be at rest. So it is almost at rest, very slow process. It is called as quasi-static process. Technically, if you read the last line, it is a process where it is slow enough for the system to remain in internal equilibrium. Sometimes what we do, we make the system to slowly accept the changes. In that, even if the heat is supplied, it will not reflect in the del U. You know why? Because when the heat is supplied and piston is allowed to move, imagine, understand the concept, system is there, heat is giving and the system is slowly moving, very slowly, quasi-static. What will happen? Whatever heat you are supplying, it must change del U. If del U is changing, del T must change, temperature must change. But what will happen? By the time temperature is changing, there is a heat exchange happening between system and surrounding. So it is not visible on the gas. This kind of process is called as quasi-static process. It means if you want to maintain temperature as constant by supplying heat, see what you want. You want system where I will supply heat, but I don't want my temperature of gas to change. Possible. I am giving burner below. What will burner do? Heat the gas. So as per the logic, it must increase temperature, but there is a way you can make heat below, but no change in temperature. How? If you are having a quasi-static process and these valves are diathermic valves, isn't it? So what is going to happen? When the heat is supplied, slowly piston is moving up. As the piston is moving up, the heat exchange happens between system and surrounding. They come in equilibrium. That is how we maintain. This process is called as isothermal process. We will talk about this today. So if a question comes in examination, what are the conditions required for a process to be isothermal? What will be the answer? The process must be quasi-static. And second condition is the walls of the system must be diathermic or conducting, whatever you want to write. Is it clear? Because if the walls are not conducting, it will change the temperature. If the process is very fast, once again change the temperature. So for achieving isothermal process, what you need is the process to be quasi-static as well as the process to be having diathermic walls, that is walls which can allow the exchange of heat between system and surrounding. Is it clear to you? I hope it is clear to you. Fine. So now we are going to talk about different kinds of processes. So basically in this chapter we have 4 kind of process. So that is the most important part of this chapter. If this is today done, chapter is almost done. After that, we have basic about heat engine and Carnot cycle. I'll talk about that also. But the main thing in this chapter is this only. The four kinds of process, namely isobaric process, isochoric process, isothermal process, and adiabatic process. Now, as the name is saying, isobaric. Iso means constant. Baric means pressure, isn't it? So, constant pressure is called as isobaric. Choric means volume. Iso means constant. Constant volume is called as isochoric process. Thermal means heat. Iso means constant. Constant temperature is called as isothermal process. And finally, adiabatic, where heat 0 degree means what? There should be no exchange between system and surrounding. Heat must not exchange between system and surrounding. So again the question may come, what are the conditions for a process to be adiabatic? Opposite of what you learned in the previous thing. First thing, the walls must be adiabatic. Yeah, yes, walls must be adiabatic, that is no exchange of heat should be allowed between system and surrounding. And second is, the process must be fast, not very slow. Are you getting my point? So what is the requirement of isothermal process? The requirement of adiabatic is exactly opposite of it, right? So what you are going to do after this? We are going to talk about each process. We are going to apply first law of thermodynamics in each process, and also we are going to find what is the work done in each process. In school examination, in any competitive examination, the question mainly comes from the work done. What is the work done during isobaric process? What is the work done during isochoric process? What is the work done during adiabatic process, or what is the work done during isothermal process? That is very important. So work done finding is very important. Okay. So let us do one by one, and we will go with the first process, that is isobaric process. So isobaric process, what I told you, it is a process where the pressure stays constant. So if the pressure is staying constant, then there is no change in pressure. And example I am giving, what is the example of isobaric process? Is boiling of water on the stove, where the pressure stays constant, because see, atmospheric pressure is acting on it, right? And we are allowing the exchange of heat between system and surrounding, pressure is getting balanced. There is no like pressure is changing, increasing, nothing is happening. So normal boiling of water or cooking of food in open container, not pressure cooker. If it becomes pressure cooker, then things will change. But in normal cooking, what you are doing, that is heat supply and cooking the food, it is a basic example of isobaric process, where the pressure is not changed. Temperature may be changed, volume also may change. Heating the water, water may expand initially, isn't it? So we may have change in volume, change in temperature, but we will not have change in pressure. That kind of process is called as isobaric. Sometimes they may ask in the school exam, example of isobaric process, boiling of water, right? Again, if I say boiling of water in pressure cooker, it will not be isobaric. Are you getting my point? So only in the open container, be very careful about this. So let us talk about the, let us talk about the work done. So if you see the work done formula, yes, work done during isobaric process. So work done, the formula is P del V, isn't it? So just P into V2 minus V1. So what happens when you are heating the gas, its volume will change, isn't it? Its volume may expand. Pressure is constant, but volume is changing. So how much is the work done? P into V2 minus V1. So suppose how the question can come, if I am having a container, in this container I have some gas. For example, if I am having oxygen gas and it is having some volume, and if you are supplying heat to it and trying to maintain constant pressure, and the volume of gas has increased from 30 centimeter cube to 60 centimeter cube, what is the work done? What will be the answer? Whatever pressure is there given, suppose they have given pressure as 2 into 10 to the power minus 4 Pascal. Then this value is given, you will do V2 minus V1, multiply both, get the work done. Are you getting? So here the work done is very simple, pressure will be given to you, constant pressure, and initial volume will be given to you, final volume will be given to you, multiply, get the answer. Sometimes it will not be given this directly, like how the questions came, no, today, 2 questions. They may give 1 gram of water is becoming this much steam. So 1 gram of water, how much, what is the volume you should find, and steam volume will be given. Subtract both to get the change in volume, and then multiply with pressure, what is given, to get the value of work done. Simple. And I hope there is no doubt in this. Any doubt in this? I don't think much doubt should be there. So, applying first law of thermodynamics, I told you, in each process what we are going to do? In each process we are going to find the work done, and we are going to apply the first law of thermodynamics. So, what will be the formula? The same thing, del U plus P del V. Nothing changes. Del U will find, change in internal energy, and P and delta V will find. That is the formula, that is the first law of thermodynamics applied on isobaric process, and this is the work done during isobaric process. Clear? On the right hand side, actually they have drawn a PV diagram. So, I think in the syllabus we don't have, earlier we used to have indicator diagrams we used to have. Indicator diagram means a graph drawn between any thermodynamic variable. It can be pressure, volume, temperature, pressure, anything. So, what is the, I mean, if there is a graph drawn where you are representing thermodynamic variables, that graph is called as indicator diagram. Yeah, like this one. So, any graph, suppose I am drawing a graph like this here, and in this graph I am writing pressure and volume and drawing a graph like this. This is a PV diagram or indicator diagram. Most used indicator diagram is PV diagram. It can be PV diagram, VT diagram, PT diagram. It can be PV, VT, PT, all are possible. But most used indicator diagram is PV diagram, in which you can understand whether what is happening. See here, if you see what is happening, at a constant pressure volume is increasing, isn't it? Expansion is happening. By seeing itself you can say the pressure is remaining constant but the volume is increasing. One thing you should remember about PV diagram is area under PV diagram gives what? Work done. Area under PV diagram gives work done. Sometimes in the exam they will give you P coordinates, V coordinates, initial, final, and then they will ask you to find the work done. What you will do in a graph, you will plot PV, again P1 V1, P2 V2, join the line, find the area below it. One triangle, one rectangle, or one triangle, one square, or maybe anything. Are you getting? If suppose, not in this question, this is isobaric, so pressure will be constant. But if suppose I give you the value of P1 V1 in terms of coordinates, I give you P2 V2 in terms of coordinates, and I ask you what is the work done from here to here. What you will do? You will plot this P1 V1, P2 V2, then join the line, then this area you will find, you will get the answer for work done. This kind of question used to come in the school itself, but now they have removed this portion from the school level. But still in the competitive class I will talk about this. In competitive class this is required, where P1 V1 will be given, P2 V2 will be given, and then find the area under it, you will get the value of work done. Is it clear? It is important for the competitive examination. For school exam I think this is not there itself. But I hope you are understanding this graph. So here what they are showing, pressure is a constant and volume has increased. This is a graph of expansion. Same graph, if I make the sign opposite, what will happen? What is this graph?
Repulsion, sir.
Huh?
Repulsion, sir.
Repulsion, compression.
Compression, sir.
Yes, compression obviously. Obviously compression. Here the volume is reducing and the pressure is remaining constant, it is compression. So expansion, compression, both graphs can be drawn. Just by the arrow direction, the meaning is changing. If arrow is towards right, it is expansion, towards left, compression. Are you getting? So this data you should be able to find out from the question, right? Next, if I go to the next process, I think isochoric will be next. So isochoric is the process in which the volume is kept constant. Very simple. Same, something like CV. Something like CV. What we are going to do? We are going to have a system. In this system, we are going to have a piston, and this piston will be locked piston. It cannot move. What will happen? Whatever heat energy you supply, how it will be used? It will be used to change the temperature, internal energy, and the volume remains constant. So here what will be 0? Del U will be 0, isn't it? So let us apply all these things in the equation and get the formulation. So what is going to happen? Del V is going to be 0, P and T will be proportional. Example can be pressure cooker, best example. What we do? We keep everything, lock it. Before whistling, whistling happens, volume has changed, some steam escaped outside, isn't it? Before whistling, the pressure cooker is example of isochoric process, where the volume is kept constant. If it does not whistle, it will remain isochoric, but it may become a big accident, isn't it? Because
So work done will be 0 in this case, right?
work done will be
0, right?
obviously 0, because del V is 0, P del V will become 0, work done will be 0, right? So the graph is drawn here, where there is a constant volume, but the pressure is increasing linearly. Can you see how the pressure is increasing? That's why the pressure can cause hazards. Pressure cooker, if that whistle is blocked by something, no, it can blast also. It has happened in many places. So why it can blast? Because the pressure keep on increasing. If it is not releasing outside, it will blast only finally. It will break the steel or the aluminum cooker. That is happening in some places, right? So let us talk about the work done. As Abhinand told very correctly, the value of work done will be how much? 0. Leah Varshini, why is your video up here? So delta V is 0, so work done will be also 0. Now let us talk about first law of thermodynamics applied. Del Q will become equal to del U plus P del V. Del V is 0, second term is 0. So what is del Q? Del U. So in this question, if they give you initial energy of system, final energy of system, subtract both, find the heat energy supplied. Or they may give heat energy supplied, from that found how much is the change in internal energy. Are you getting my point? Sometimes they may give you in terms of molecular energy. You have to solve and find it. But understand the concept here, this second term will not be there, because volume is constant, del V will become 0. Is it clear? Very simple. Isobaric, isochoric is always simple. What confusion can happen? It can happen only in isothermal and adiabatic process. We will come to that. Shall I proceed further? Can I proceed?
Yes, sir.
Okay.
Yes, sir.
Okay. So now comes isothermal process, and as the name says, the process where the temperature is kept constant. I told you how it is possible. Remember that it may come in the exam also. For achieving isothermal process, you must have two conditions. One condition is quasi-static process. The second condition is diathermic walls. Because only if you have quasi-static process and diathermic walls, you are going to have constant temperature. Otherwise, the temperature will change. So if you see what is going to happen here, since delta T is going to be 0, we know that PV is equal to nRT, and delta T is 0, then PV will become equal to constant. That is, delta T is 0, temperature is constant. Generally, what is the formula of ideal gas? Ideal gas equation says that PV is equal to nRT. For 1 mole of gas, N becomes 1, PV is equal to RT. Now R is a constant, gas constant, T is also becoming constant. This both will become constant, so I can write PV is a constant, isn't it? That's what is written here. How it has come, I have explained it to you, there is nothing else. So in the case of isothermal process, now if I draw the graph, what is going to be constant? Temperature is going to be constant, P, both will change. See there, P is changing, V is changing, but temperature is remaining constant. That is the graph of expansion obviously, and if you want to find the area, you will get the work done. Fine. Let us try to find the work done with numerical method, with mathematical equation. Reason is, we cannot find this area being a curve. When you go to the 12th standard, one chapter is there, application of integrals, where they will say you how by using integration you can find. Here also we are going to do the same thing, we are going to use integration only. So whenever there is a curved graph, rather than doing the, how can you find, this is not triangle also. So you cannot use geometrical formula, we have to use integral formula. So we are going to find the area under this curve by using integration. So what is the work done formula? Work done formula is P del V, isn't it? So let me directly go into that. So here they have talked about first law of thermodynamics applied now itself. So in the case of, yeah, you should remember this also. If the temperature is remaining constant, then del U also will remain constant. Remember this. If del U is remaining, del U will become 0 because U remains constant. If U remains constant, Ui becomes equal to Uf, del U becomes equal to 0. So in the case of isothermal process, del Q is P del V, that is W. In isobaric process, del Q is equal to del U plus P del V. In isochoric process, del Q is equal to del U. In isothermal process, del Q is equal to del W. Are you getting? Remember this. Okay. Then now the thing is, we are going to find the equation of this thing. I am going to solve it in next page. So how to find? Let us derive this. So we know that work done is equal to integral of P del V, right? This is the formula in this case, in this chapter. So now the volume is changing from V1 to V2. So the formula of work done will become equal to integral of P dV from V1 to V2. Now what is P? Force by, don't go in that, that terms. PV is equal to nRT, right? Can I write like this? So from here I can write P is equal to nRT by V. I hope you are getting this. If P is equal to nRT by V, I am going to write work done is equal to integral of nRT by V dV from where to where? From V1 to V2. You may ask, why don't you directly integrate P into V? No, because here P is linked with volume and volume is a variable, not a constant, right? Now nRT, everything is constant. R is gas constant, number of moles, and T is temperature, is constant in isothermal process. It will come outside, work done will become equal to nRT outside integral of 1 by V dV. What is integration of 1 by x dx?
Log x.
You should not say log. Which log? Which log? Which log?
Natural log.
Natural log, very important. Not log base 10, natural log. So integration of 1 by x dx is actually ln x, you can say, or log base e, both are same only, isn't it?
What?
What is this you are asking, Abhinand? Pure science student. At least you know the formula 1 by x dx is equal to log x, that integration.
No, I thought in the first. No,
I
the
taught.
summer class,
Yes, I taught. But
Yeah.
if you want someday come, I'll teach you about this natural log. And natural log means log base is e. E is how much? 2.303. Not knowing all these things. Okay, leave it now.
No, I don't.
Leave it. I'll talk some other day. Just remember that 1 by x dx is natural log x, not log base 10. Log base 10 is different from natural log. But you can convert. This also you should remember for this chapter. Log base e is always equal to 2.303 log base 10. This is very basic things you should know from logarithm. It will be used here in this today's derivation. So always remember log base e is 2.303 log base 10. And I'll come to that. So what is the 1 by 1 dV integration? 1 by 1 will become ln V. So work done will become equal to nRT into ln V. Where is the limit? From V1 to V2. Put the upper limit minus lower limit. It will become nRT into ln V2 minus ln V1. Am I right? So log A minus log B is log A by V. You know this? So I can write work done is equal to nRT ln V2 by V1. Remember this. Or if you want to write the same thing in terms of natural log, that is log base 10, most used, then I can write W is equal to 2.303 nRT log base 10 V2 by V1, because generally you are familiar with log base 10 only. And since P1 V1 is equal to P2 V2, this also is known to you. P1 V1 is equal to, because PV is constant here, no? P1 is equal to P2 V2, I can write V2 by V1 as P1 by P2, right? Yes or no? this P1 by P2. So I can replace here. It can also be written as 2.303 nRT log base 10 P1 by P2. Is it clear to you? This derivation is coming in the school examinations frequently. This is the work done during isothermal process, where what we do, first we take the equation of work done, integration of PdV, and P we can write in terms of nRT by V, and nRT is constant coming outside. 1 by V dV integration is ln V, that is natural log V, and the natural log V we are putting the limits, upper limit minus lower limit, and natural log is equal to 2.303 log base 10, putting that value here and getting the work done value in terms of volume, in terms of pressure. Both are fine. Both are work done during isothermal process. If you have any doubt, feel free to ask me. If you have any doubt, feel free to ask me. If there is no doubt, yes, something.
It's not completely sir, because I'm not familiar with the sir.
Maybe these things only you have a problem, right, Abhinand?
Yeah, sir. Other than I'm clear.
But you remember now. For now, I can say remember this. Someday you come, I will teach you, or you can meet Sadiq sir also for this.
Remember this one, the whole thing.
Yeah, that is this you know 1 by x dx is equal to log x. This you know already.
Yes, yeah.
Yeah, just remember that log base e is 2.323 log base 10. That's all you remember.
Okay, got it.
Okay.
Sir.
Yeah. So Anshu, something you are saying, please. Yeah.
So like how are we supposed to solve the natural log?
How is supposed to solve in this sense? If a numerical comes, you are saying.
A numerical comes.
If a numerical comes, always convert natural log into log base 10, right? And once you make log base 10, then they are knowing that you don't have calculator in your examination. So how they will give you question, they will give such a way that V2 by V1 will become 10 to the power something. I'll give some numericals to you. How it will become, I'll tell you. It will become like log base 10, 10 to the power 3. Now this formula you know. What is this formula? Tell me. Anshul?
3.
Very good. 3 log 10, 10. What is the log 10, 10? Log A base A is how much? Anshul? 1, obviously 1. So answer will be 3. So they know that you are not knowing, you are not in calculator in the examination. So they will give the value also to you in such a way that you can use this kind of conditions. What is going to come in physics is these two properties only. That is log, if I am writing somewhere, here I am writing, if you are able to see. Log A power B is B log A. Okay, this property is used. Next property that is going to be used is log, I told here, no, A base A is equal to 1. And Abhinand, you also note these things here. Very basic log actually. Log A log A minus log B is log A by B. Log A plus log B is log A into B. Log A power B is B log A. Log A base A is 1. These things are very basics of log. If you are a math student, I know log is not there in the syllabus, but I think you should know this basic math. If you are not knowing, I have told you what is required of physics, I have told you. In physics, they will not go beyond this. In math, JEE, they may go much beyond. But in physics, in the whole 11, 12 physics, what maximum they can use log is up to here only. That is, they can use log, this formula, log A power B, log A base A, and this thing, log E is 2.0 log 10. That's all they will use, nothing much they will use. So if you are knowing this much, any log based questions you can solve in the school examination or competitive examination also. If it is clear, if it is fine, then copy this fast. I'll go to the next page. I'm giving 2 minutes of time. Yeah, tell me, Shivaranjani.
Sir, suppose if V1 is greater than the V2, then it will be like work done on like that.
If V1 is more than?
V2.
Okay, so you are telling if I am getting the answer is negative.
Yeah.
Yeah, then yes, if it is negative, you have to use sign convention. You will say that since the work done is coming as negative, the work is done on the system. Like that you should say. Okay?
Yes, sir.
Okay. So if you are copying, I am giving 2 minutes, please copy fast. One last topic is there, I will finish that, then I will close the class. Let me know if you are done. Even if you are not writing, you can write it later. It is there, going to be there in the clip in the video.
Done, sir.
Okay, I'll move to the next part. If you are not writing till now, please write it later. Let us complete because next topic is little bigger than this. So I want to finish the topic today. That's why I am asking you to write it later. Can I go to the next page if you allow me?
Yes, sir.
Thank you. Shivaranjani, Adityaraj, your video is off. Please make sure it is on. Okay. So next we are going to talk about adiabatic process. I told before some time, it is a process in which no exchange of heat is allowed between system and surrounding. Same thing is written here also. See what is written? Occurs without transfer of heat or mass between the thermodynamic system and its surrounding. So any process where heat exchange is not allowed between system and surrounding can be called as a adiabatic process. In adiabatic process, I told you what are the conditions required for it. First thing is walls must be insulating, that is adiabatic. The walls must be insulating, and second thing is what? Fast, yes. The process must be fast, not like slow. Process must be fast. These two are the conditions required for what? For adiabatic process. So they ask in the examination, what are the conditions needed for a process to be adiabatic? These two are the conditions required. Okay, let me proceed further. So in this case, yeah, this is very important. Earlier in the syllabus, I'll tell about this to you a bit. Now if you see NCERT book, only this is given in NCERT book. They have talked only about one relation between pressure and volume. Basically, in competitive exam I will teach this also, but not required for school examination. That is adiabatic relation between pressure, volume and temperature. See, if you think, you will realize, in the case of isobaric process, pressure was constant, V and T had relation. In the case of isochoric process, volume was constant, P and T had relation. In the case of isothermal process, temperature was constant, had some relation. In the case of adiabatic process, neither P nor V nor T is constant. Everything is variable. If everything is variable, we are deriving or we are knowing the adiabatic relation between all three quantities, that is pressure volume, volume temperature and pressure temperature. That topic is there, not in syllabus now, in school syllabus, but it is still there in competitive syllabus. But in school syllabus, what they are knowing is, what they are using is adiabatic relation between pressure and volume. So remember, adiabatic relation is PV power gamma is a constant. Now what is gamma? Gamma is the ratio of Cp to Cv. Yes, it will be again coming in the next chapter, last chapter from us, KTG. In kinetic theory of gases, they will be using gamma is equal to Cp by Cv. Very frequently they will be using that. Okay, so the equation, this is called as adiabatic relation between what and what? Between pressure and volume. Like that we have for volume temperature also, and we have a pressure temperature also, but not required now for you. P power minus gamma is constant. Leave that, leave those things. Now you just remember pressure and volume, the adiabatic relation is PV power gamma is a constant. Okay. Now let us directly go into the derivation of this because we don't have much time. So I am going to do the derivation. Yes. So in the previous derivation, we know how to find the work done. Work done will become equal to integration of P dV from V1 to V2, right? This we know very well. But here I cannot write PV is equal to nRT because PV is equal to nRT is only for ideal gas. Here what you should write? Here you should write PV power gamma is a constant. Can I write like this? I will give time for writing. I will give you clip for writing. Now you understand the derivation. It is the most difficult, I should say, derivation, but simple only if you understand it. So please pay attention. Don't be in a sleepy mood, Sugendran. Shivaranjani and Adityaraj already are out of focus. So please pay attention and understand the derivation first. Okay, copying is secondary. Don't waste your time in copying now. Understand the derivation. Okay. So I said that.
Okay, sir.
Yeah. Thank you, Sugendran. Adityaraj, I hope he left and he slept already. PV power gamma is a constant. If PV power gamma is a constant, then I can write P is equal to K by V power gamma. Why I am doing so? Because I want to write P in terms of V now. So I can write this as work done is equal to integral V1 to V2, instead of P I am writing K V power gamma, can I write V power minus gamma into dV? Yes, can I write like this? Now I'll take K outside, V1 to V2, it will become V power minus gamma dV. Now the integral formula, integral of x power n dx is x power n plus 1 by n plus 1, right? I hope all of you know. Abhinand, integration of x power n dx is x power n plus 1 by n plus 1, right? So, once again I will keep it here, yes. So, work done will become equal to K integration of, what is this thing, why I am writing integration, here I cannot erase also, okay. So, V power minus gamma plus 1 by minus gamma plus 1, where to where the limits are? From V1 to V2. Do you agree with me? I hope you agree with me. So, work done will become equal to K into, I will take this as outside 1 minus gamma, it is a constant, and here I am getting V power 1 minus gamma. So, if I am putting the upper limit minus lower limit, it will become V2 power 1 minus gamma minus V1 power 1 minus gamma. Anybody has problem in this? I am going step by step slowly. Anybody has problem up to here? I don't think.
No, sir.
Yes, I already told you PV power gamma is a constant, right? I told you in the beginning itself. I can write this as P1 V1 power gamma, or I can write it as P2 V2 power gamma, that is a constant. You know very well what is how it is written, isn't it? Same like Bernoulli's theorem, you remember? Any constant we can write like this. Anyhow, coming further, so I can write work done is equal to, I am sending K inside now, so I can write K into V2 power 1 minus gamma minus K into V1 power 1 minus gamma divided by 1 minus gamma. Do you agree with me? I hope you are understanding this. Next, I am going to put the value of K. In this case, I have V2, so I will put V2. Here I have V1, I will put V1. So, here I will write P2 V2 power gamma into V2 power 1 minus gamma. I can write V2 into V2 power minus gamma. I can write like this. I am saying understand what I am doing. I am separating it, writing. It is 1 minus gamma, right? So, I can take the base same and I can change the separating the power, V2 power 1 and V2 power minus gamma. If you add both, it will become 1 minus gamma only. I hope it is clear. Minus,
Got it.
any problem, Abhinand?
No, got it, sir.
Yeah, P1 V1 power gamma, V1 power 1 into V1 power minus gamma. Is it clear what I am doing? Divided by 1 minus gamma, obviously. Is it clear to everybody, yes or no?
Yes, sir.
Step by step I am going, please pay attention. What happened? Understood? I hope. Then now what we can do, these two can get cancelled, these two gets cancelled, these two gets cancelled, it became simple. Work done during adiabatic process became P2 V2 minus V1. If I take P1 V1 minus P2 V2, down I will write gamma minus 1, nothing else. Can I write like this? If I want to write, huh?
P2 V2 is positive and P1 P1 is negative, sir.
Yeah, but I have changed it, so that's why in denominator I have changed, no?
Okay, fine. If you do everything, okay.
Yeah, anybody else, something that you are saying? I hope no doubt. And then I can also write PV as nRT. So I can write nRT1 minus nRT2 divided by gamma minus 1. So that can be written as work done during adiabatic process, can also be written as nR if I take common. So nR by gamma minus 1 into T1 minus T2. So work done during adiabatic process in terms of pressure and volume can be written as P1 V1 minus P2 V2 by gamma minus 1 in terms of temperature can be written as nRT1 minus nRT2 by gamma minus 1. I hope it is clear. This derivation comes in school exam very frequently. Derive the work done during a adiabatic process. Is it clear to you? Is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Now this is the most important part of today's class, because I said you today, out of all the 4 process, I know what you will forget in examination is adiabatic only. So that's why I told you, understand it. And where you will forget somewhere here. You will confuse what happened suddenly. Now you are understanding, but I am telling you, you are going to miss here. If you don't want to miss here, then understand this whole derivation. I hope you are getting my point. Anybody has doubt, feel free to ask me. If there is no doubt, then we can wind off today's class. This derivation you can copy later from the YouTube. I will send the link in the group. Go to that part and copy the notes. But again I am repeating, next class we are going to finish thermodynamics, almost over now. Some last thing, and next class will be focused more on numerical solving. Okay, we will take numericals of this chapter and we will start KTG. Now KTG is small chapter. Now almost we are towards the end of the syllabus. So next class I will spend on solving more numericals from thermodynamics and doing some part of remaining chapter, that is the second law of thermodynamics and heat engine, some basic things, right? That's heat engine only. I'll talk about Carnot engine also. If everything is fine, then we can wind off. We will meet again on the next class, and till then take care. Bye bye. Good night.
Thank you, sir.
Yeah.
Thank you.
Sir, just keep the screen on, sir.
Yeah, I'll keep it on. Those who want to copy can copy also. Yeah.